7.6, we start with a radical equation. And reminder, this is the one thing that you guys need to solve any radical equation is the first and most important thing is your radical have to be by itself. Meaning, look at A, part A, or this example 1A, which is they ask you to solve and check. And again, every time you have an equal sign, they will ask you to solve. So again, but the most important thing when you see the radical, as you will see the next problem, the first and most important thing that you need to do is your radical right here have to be isolated, meaning they have no number adding or subtracting or multiply to this radical, which is, as you can see right here, we have a radical by itself equal to a number. So as long as you have this item, life is good. Why? Because now, how do we get rid of the radical? Well, to get rid of the radical, we need to square them, because a square and a radical, they will cancel it out, right? Which is, again, if I square on one side, I have to square on the other side, which is, again, I square the square root, which is the square and the square root cancel out, and I square the 7, which is, in this case, this is what I have, which is, like I mentioned, a square and a square root, they will disappear, because a square, a radical, double the radical, or not double, like the radical times the same radical, just the item on the inside coming out, right? And again, 7 squared, which is 7 times 7, would give you 49. As you can see, after one step, after you square both sides, now this is the easy problem, ladies and gentlemen, right? Why is easy? Because how can I solve for x? We just need to do the opposite operation, which is, again, we need to subtract. Subtract, we need to add, which is, again, 5x equal to 50. And we need to divide, which is x is equal to 10, right? So again, looking at this problem here, this is, like I mentioned, this is the easy type problem in terms that the radical is by itself. So what happens if your radical is not by itself? Meaning, as you can see over here, we have an extra 5 on the outside, right? We have a radical, whatever this item is, I don't care. I know that this is my radical, plus 5 equal to 6, which is, again, there's an extra number on the outside, which is my radical is not isolated, right? So now, the first thing before I can square them, the first thing I can raise the square on both sides, I need to get rid of the 5. And just like before, to get rid of 5, we need to subtract 5 to the other side, which is now, everybody see that my new problem, or this is the problem that I have, which is the radical. Whatever in the radical, I don't care, but I have a radical equal to 1, right? Which is the same as A now, right? We have some radical equals some number, which is how do I get rid of the radical, which is, again, to get rid of the radical, I need to take the radical square, and then I take the 1 square, which is, again, life is not bad now, right? Because we have whatever inside my radical come out, which is 3x plus 10 equal to 1 square, which is 1 square is 1 times 1, which is still 1, right? Which is now, this is what I have is 3x, I subtract 10 to the other side, and ladies and gentlemen, this is my answer, which is -9. And I have to divide by 3, which is, everybody see that -9 divided by 3 will give me -3. So again, I haven't do the checking part yet. But if you were to check this, everybody see right here, 3 times -3, 3 times -3, if you see this item here, if I put in 3 in this item right here, 3 times -3, everybody see that 3 times -3 is -9, which is -9 plus 10 will give me 1. And a square root of 1 plus 5 will give me 6. Everybody see that 6 is equal to 6. So the answer can be negative. I want to point out that the answer can be negative, okay? Because the reason that why I mentioned that is, again, because look at this thing here for C. If you take a look at C, you say, well, C is very similar to B. Yes, I agree with that, right? We have a radical, and doesn't matter what in the radical. If there's a number, I need to get rid of the number on the outside first, which is to get rid of that number on the outside. Everybody see that I need to subtract 10 on the other side. And again, looking at this thing here, I have a square root of whatever the item in the square root, which is x minus 17, equal to -7. So if you look at this thing here, this is what I tell you guys, we can stop here at this time and we can say that it's no solution. Why is no solution? Because the question asks you this, pick me a number for x. Whatever you can pick, I don't care. Pick me a number, whatever number you can pick. You can pick positive number like here or negative number like here. Pick me a number for x, I plug it in, I subtract 17, and then I take a square root of that result, and it's give me a -7. Remember, if you remember in prior chapter, like 10.1, 10.2, 10.3, and 10.4, we say that there is no way you can take a square root of something and give you a negative number, right? There's no way you can take a square root of something and the answer is negative number, because if you take a square root of a negative, it's imaginary, it's undefined, it's no solution as of now, right? But again, let's take a look at this thing here. Let's say that you don't see that you cannot take a square root of number and give you a negative. Let's say we do what we've been doing, right? This is what we've been doing is, again, you don't have to do this step. I just want to show you that if you were to do it, you will see that this is what we will get, right? So if you take a square root on both sides, as before, which is a square root side, you have x minus 17 on the outside, -7 times -7 will give you 49. And then you add 49 to that side, which gives you x equal to 66. And you will probably say, so what's the problem, Mr. Tran, right? What's the problem? Well, take a look at this thing here. If we plug in 66, I haven't checked on B because A and B, the answer is correct. But again, let me take a look, or let me check this item here, which is, do you agree that this is what I have, which is 66. I plug in for x, which is 66 minus 17 plus 10 equal to 3. I just plug into my original item right here, right? Wherever my x, I plug it in here, which is, that's where my 66 come in, right? So again, now, do you agree that 66 minus 17 will give you a square root of 49? Which is, what is a square root of 49? Do you agree that the square root of 49 will give you 7, right? Which is, again, 7 plus 10. Do you agree that 7 plus 10 is not equal to 3? We have 17 on one side, we have 3 on the other side, which is these two items are not the same. And because it's not the same, that's why the 66 is not your answer, okay? So again, that's the idea here is, I haven't checked, but you guys have to check yourself. You guys have to check the answer. If you have a square root of something and it's equal to a negative number, for now, if you have a square root of something equal to a negative number, that is undefined. That is no solution. There is no solution for that particular problem. So again, this problem here, the answer is no solution. There is no way you can pick me a number and you plug into that square root and then you take a square root and the result is a negative number. Okay, so that's the idea here. I just want to give you guys that item here. And again, the answer can be negative, can be positive. I don't care. Those two answers can have it, but you cannot have a square root equal to a negative number. Okay. So question with this 3 problem here. Question with this 3 easy, hopefully easy problem, because this is where we stopped last time. This is where we stopped on last Thursday. And question with this 3. So here come a small, let me erase this, and then here come a small obstacle, right? Small obstacle that we run into in term of 10.6, which is, looking at this thing here, first of all, everybody agree that we have a radical square root of 7x minus 3, that's by itself, equal to x minus 6, which is, life is okay, right? We have a radical equal to something, right? So the radical is isolated. We don't need to manipulate to get the radical by itself, right? So looking at this thing here, what can I do? Well, if we go with our steps, do you agree that to get rid of the radical, I need to take a square on both sides? So I square on the left side and I square on the right side. And hopefully this is where you see, oh, Mr. Tran, you bring me back to chapter 6, which I don't like, right? Which is, again, looking at this thing here, do you agree that on the left side, a radical and a square root, they cancel each other out? On the right-hand side, we have x minus 9 square. which is if you remember the special product, you can do your special product. If not, x minus 9 squared is the same as x minus 9, x minus 9. Which is once you have x minus 9 times x minus 9, everybody see that we need to FOIL this out, which is if you FOIL on the right hand side, you have x squared times minus 9x plus 81, right? X times x, right? This is what we have, which is again x times x to give me x squared, x times negative 9 to give me negative 9x, negative 9 times x to give me negative 9x, and negative 9 times this to give me 81, right? So that's what we have, which is again, once we have that, which is we have to combine like term, right? And if you combine like term, this is what you have, negative 9 and negative 9 will give you negative 19, right? But now everybody see this is where my problem come in. For those of you who recognize it, we have an x squared equal to something. And if we have an x squared equal to something, reminder, how can we solve for x squared? How can we solve for x squared? Which is, again, to solve for x squared, this is what we need to do, is we need to set the item equal to 0. And again, if I set the item equal to 0, all I did was I moved the negative 7. Again, I moved the 7x by making a negative 7x, and I moved the 3 by adding 3, which is, again, this item over here. This item over here, I just move it to the other side. See that? So again, I move the 7x by subtract the 7x. I move the negative 3 by add a 3, which is, again, why do I do